Hi students, today we are going to look at the learning target. How are two-step equations solved? So if you want to take a moment to pause your video right now so that you can write down this information, pause as needed. And of course you can always go back if you need to watch something again, because I'm going to move kind of quickly. So when we talk about solving two-step equations, there are a few important understandings. The first understanding involves inverse operations. So you're going to hear that language being used throughout this entire unit. So let's look back at what inverse operations actually mean. If you recall, the word inverse actually means opposite. Okay, so for example, addition is the inverse of subtraction, okay? Because they undo each other. So I could say that the opposite of adding 5 would be subtracting 5, or the opposite of subtracting 100 would be adding 100. So they're inverse operations of each other. Likewise, another set of inverse operations would be multiplication and division, because those are opposites. They undo each other. So if I multiply by 5, the opposite or inverse of that would be dividing by 5. If I divide by -10, the opposite of that would be multiplying by -10. So those are inverse operations. So when we talk about solving two-step equations, this is the first essential understanding, is that inverse operations undo each other. So the second part of that is when we look at an equation. For an example, let me just kind of give you a basic equation. I'm gonna not even use a variable here. I'm just gonna give you an equation. Let's say something like 6 plus 2 equals 8, okay? Which is a true statement. So that's all an equation is, okay? So it's a math sentence that is equal to each other, okay? Both sides are equal. I just don't have a variable in here yet. But this is true, and looking at this equation, I can do whatever I want on either side of this equal sign as long as I do it to both sides. So for example, let's say I wanted to take 6 plus 2 and I wanted to maybe add 1. That's okay as long as I also add 1 to that side. So 6 plus 2 plus 1 gives us 9. 8 plus 1 gives us 9. So see how it's still equal? So I can do whatever I want to this equation as long as it is done to both sides so that it remains equal. Now we are going to use variables in place of some of these numbers. Let's jot down though those two important understandings, and I am actually going to put a remember, and I'm going to put a nice big kind of cloud around that so that really stands out on my paper. I really want to make sure that I am remembering these important understandings. So the first thing we said, first thing to remember, is inverse operations are going to allow us to isolate the variable or get it by itself. So that's your first important understanding, okay? So we are going to perform the inverse operation, to isolate the variable, okay? So we can see what it is equal to. So we'll look at an example of that in just a moment. And then the second most important understanding is whatever you do to one side of the equation, you have to do to the other side. Okay, so what you do to one side of the equation, you must do to the other. What you do to one side of the equation, you must do to the other. Okay, if I'm going too fast for you, feel free to pause and rewind your video as needed. All right, so those are my two important understandings that I am going to repeatedly come back to in this unit. Okay, those are the most important things to remember. All right, so we are going to go ahead and take a look at a two-step equation now, and we are going to follow some certain steps that are going to be very common for every single two-step equation that we solve. Okay, so over here on the left-hand side, I'm going to list out the steps that we're going to take. And then on the right side of my paper, I'm going to write an example so you can see what each step looks like. Okay, so first step, we're going to write the equation. Okay, now this is not always going to be necessary. Sometimes, like if you've got a worksheet or something, if you're printing something out, that equation's already going to be written for you. But if it's not, that's going to be your first step, okay, is writing out that equation. So let's go ahead and take the equation. Let's say 4x minus 2 equals 10. So if I give you this two-step equation, and this is called a two-step equation because there are two things being done to the variable x. So I am multiplying the variable x by 4, and I am subtracting 2. And if I do that, okay, I need to solve for x so that this equation would be true, that 4x minus 2 would equal 10. So I'm trying to find the value of x that would make that true, okay? So start off by writing the equation. Step 2, make sure you're writing the steps down too. So the first thing that we're going to do is when we talk about these inverse operations, I want to undo any addition and subtraction, okay? So think about working in reverse order of PEMDAS, your order of operations. Please excuse my dear Aunt Sally, however you remember those, okay? So you want to undo any addition and subtraction first, okay? And again, that's that inverse operation, okay, that we talked about up here. So when I come over here and I look at this example, we said that we are multiplying the variable x by 4 and subtracting 2. So I want to undo this subtraction by 2. So what's the opposite or the inverse of subtracting 2? Well, that would be adding 2. So I'm going to go ahead and add 2 and then think about that second remembering that we had here. What you do to one side of the equation, you have to do to the other. We got to keep it balanced. Okay, so we looked at here, like if I add 1 to the left side of the equation, to the left side of the equals, I've got to do the same thing on the right-hand side, okay, so that it keeps balanced. Okay, so if I'm adding 2 on the left side of this equation, I have to come over here and add 2 to the right side of the equation. And if you prefer, you can put up a little wall right there at the equal side so you can keep track of what both sides of your equation are. Okay? All right, so then let's simplify what we have. And that is step 3. Okay, we are going to simplify what we have left here. So I have on the left-hand side of this equation, I'm going to keep bringing my wall down here, I have 4x minus 2 plus 2. So when I simplify that, all I'm going to have left over is 4x. Okay, so negative 2 plus 2, those are inverse operations. They're going to cancel each other out. Okay, and then on the right-hand side of the equation, we have 10 plus 2, which is going to give me 8. Oh, sorry, went the wrong way. I subtracted. 12. 10 plus 2 is going to give you 12. Sorry about that. Okay, now here's where the second step comes in. So we undid the subtraction by adding, and now we're going to undo the multiplication. So that next step is going to be undoing any addition, or sorry, any multiplication and division second. Typically, when you solve a problem, this would be the very first operation that you would do to solve a problem, but now we are kind of backing it up. We're trying to get back to the beginning. So reverse order of operations means we're going to undo the multiplication and division second. So if I look at what I have left here, 4x equals 12, I see now I'm multiplying the variable x by 4. So what is the inverse or opposite of multiplying by 4? Well, the opposite of multiplying 4 would be dividing by 4. So I'm going to divide by 4 here. Okay. And again, our second most important understanding, what you do to one side of the equation, you must do to the other. Again, to keep it balanced, okay, like we did here. So if I divided by 4 on the left side, then I also have to divide by 4 on the right side, okay? Then we simplify what we have. So 4 divided by 4 cancels out, leaving us with just x equals, and then 12 divided by 4 gives you 3. So our solution would be x equals 3. And that is step 5. Okay, so you clearly give the solution. X equals. Okay, so there's your solution right there. X equals 3. The final step is your check step. Okay, you need to make sure you're doing a check step, because if you possibly made a mistake, this is where you will catch that mistake and you'll automatically know if you worked this out correctly, if you solved the equation correctly. So it's like instant gratification. You're going to know right away if you did it correctly or not. So the check step works like this. We're going to take our solution of x equals 3 and we're going to substitute it back into the equation, the very original equation. So we're going to go all the way back to the beginning and we're going to plug 3 in for x, okay? Now remember, this means 4 times x. So when I substitute 3 in for x, that means 4 times 3, not 43, okay? So 4 times 3 minus 2 equals 10, okay? And if we solved this equation correctly, then this will be true. So 4 times 3, that's 12, right? Minus 2, okay, equals 10. So is this true? 12 minus 2, yep, that equals 10. And on the right side, I have a 10. And that is a true statement. 10 equals 10 is a true statement, so that checks. So right now, that check step there tells me I solved this equation correctly because I plugged it back into the equation and it worked. It made sense and it was a true statement. So right there, I know automatically that I got the equation correct, okay? In the next video, I am going to be showing you some different examples. So in the next video, we're going to work out some examples together. I'm going to talk you through them using these steps. So be sure to check out that next video right along with me and write those problems in your notes as well. All right, we'll see you guys in the next video.